Okay, it's time for another example problem. This one is from homework 2. So we've got a cat being chased by a dog. Both are running in a straight line at constant speeds. The cat has a head start of 5 meters. The dog is running with a speed of 8.3 meters per second and catches the cat after 6.4 seconds. How fast did the cat run? So as usual, we start by drawing a picture. So we'll draw some ground here. Whoops. There we go. And we've got our dog. It's a really terrible dog, but that's all right. Bark. That's how we know it's a dog. Okay, and we're going to label this. So this is the X1 for the dog. We know the cat has a head start. So here's the cat. Oh, these are really awful. There's a cat. Meow. X1 for the cat. All right, and then later, at some other distance, they catch each other. So this is at T1 right here. This is also T1, and this is at T2. So let's start writing down the things we know. We're going to go ahead and just say that where the dog starts, we're going to call that 0 meters. Since the cat has a 5 meter head start, that's going to be 5 meters, and that means I've defined the positive x direction to be to the right. So I'm going to go ahead and label that so I can keep track of it. We'll say they start running at 0 seconds. We're told that they are that the dog catches up with the cat after 6.4 seconds, and that the dog is running with a speed of 8.3 meters per second. So if I go ahead and draw that, here's the dog running that way with some velocity, and I know that the x piece of this has a size of 8.3 meters per second and is in the positive direction, right? It's pointing in the plus x direction. And we're trying to find how fast the cat ran, so we can find the x component of the cat's velocity. That's what we want to find. Okay, we are told that we've got constant speeds. So we also know we have no acceleration for either the dog or the cat. So that lets us go ahead and use our equation for average velocity. So let's just try and find it directly. This might be the first thing we try. So I'm looking for the velocity of the cat in the x direction. Well, the cat ends up at position 2, starts at position 1, and it did that in time t2 minus t1. T1 is equal to 0, so I can cross that out right away, which is nice. So we get x2 minus x1c divided by T2. Okay. Now here I know the starting position of the cat, right? That's my 5 meters. I know T2, that was the 6.4 seconds, but I don't know x2 yet. I don't know the distance that they end up at. So I can't just use this to find the answer. So let's try another piece of information we might have. We also know that the dog is running. And so the dog ends up at x2, started at the dog's initial position, And it did that in T2 minus T1 seconds. Like before, T1 is 0, and in this case we also have that the dog starts at 0 meters. So we can cross that out. So we have x2 over T2. I can rewrite this as x2 is the dog's velocity in the x times T2. And now we see that I can find x2 because I know the dog's velocity that's given to us. I know how long it takes for the dog to catch the cat, so I can find x2 and plug it in the equation up there that we just had for the cat. So let's do that. So I've got the velocity of the cat in the x direction is equal to x2, which I'm now going to write as the dog's velocity in the x, times T2 minus x1c. That's where the cat started, divided by T2. I can start plugging in numbers for my version of the problem. So I had 8.3 meters per second was the dog's velocity. T2 was 6.4 seconds. The cat started at 5 meters. And again, T2 was 6.4 seconds. So if I multiply out the 8.3 and the 6.4, I get 53.12 meters minus 5 meters over 6.4 seconds. Multiplying and subtracting and dividing everything out, we get 7.5188 meters per second. So I might round that to, hang on, we'll just erase that. We're going to round that to 7.52 meters per second. Remember, when entering numbers into long kappa, you always want to keep at least 3 digits because it's typically checking to see if you're within a few percent. So I kept more digits throughout the whole calculation than I needed, and then I round to 3 at the end. So now it's time to see if our answer makes sense. In other words, is it not crazy? So first up, are the units correct? Well, I was looking for a speed, and I got units of meters per second, so the units work, right? Next up, we can take a look at direction. Right? I found a velocity, and I got that my velocity was positive, right? I didn't end up with a negative number. The cat was running away from the dog. That would be in the positive x direction according to our picture. If we scroll up real quick here, let's see. All right. So if we look up here, we had the positive x direction going to the right. The cat should also be going to the right. All right, we'll add our cat velocity on here as well. Right, so the fact that the cat velocity turned out to be positive is also good. Right, so the direction works out. So I'll just say, where's my pointer? There we go. It's positive, so that checks out. And next we can try and get an idea about the size. How about the size? Well, we found a size of 7.52 meters per second, and that's less than the dog's speed, which was 8.3 meters per second, which makes sense because the dog has to be able to catch the cat. So we found a size that was less than the dog's velocity, so that makes sense. So our answer seems to make sense, so we could go enter it into long kappa, and sure enough, that would be correct. So hopefully this was helpful. So again, we started by drawing a picture, labeling everything on the picture, drawing and labeling everything we know by listing out the numbers, starting with just an idea, right? I'm going to use the velocity and try and figure out what the position is. We found out we had to go and grab another piece of information using the velocity for the dog in addition to the cat to get the distance we needed. We combine everything together, plug in our numbers, get an answer, and then check if that makes sense by checking the units, the direction, and the size. We'll see you on Monday.